we're talking about three-dimensional coordinates. In a three-dimensional coordinate system, you have three axes. You have your x-axis, your y-axis, and your z-axis. We're going to talk about planes. When something is said to be in the xz plane, that means it lines up flat within that plane. So anything here that doesn't go into the y plane, this doesn't deal with the x-axis at all, is in the xz plane. The zy plane, anything within the zy plane. And of course, the xy plane is anything within the xy plane that does not have anything to do with the z plane. Now let's start with the problems. 23 has the equation x equals 5. In a three-dimensional coordinate system, the equation x equals 5 will be represented this way. If we assume this is 5, we will imagine a plane at 5 that bisects the x-axis at 5 and goes infinitely forever in the y direction, forever in the z direction. Y equals -2. Here's our y-axis. We're going to pretend this is -2. And again, we have a plane that bisects the y-axis, goes forever in the x direction, forever in the z direction. Now we have y is less than 8, which is an inequality, so it's a little bit different. Let's imagine the plane y equals 8. So we assume that this is 8. This is our plane at y equals 8. What the equation is saying, or the inequality is saying, is that it's anything less than y equals 8. So every point that is below this y equals 8 plane is included. So a description would be all points where y is less than 8. So imagine a box that goes forever in the negative y direction and forever in the x direction and forever in the z direction. Now we have x is less than, or sorry, x is greater than or equal to -3. Now, if our -3 is somewhere here, we put our plane here. It's saying that x is greater than or equal to that. So if our plane spreads forever at -3, our points are everything that is above this. All points where x is greater than or equal to -3. So a box, a space, an area, if you will. Our next inequality is 0 is less than or equal to z, which is less than or equal to 6. This one can be represented by two planes. The first plane is z equals 0. So here's our plane. Here's z equals 0. So that's our first plane. Our second plane lies at z equals 6. So we're going to pretend our 6 is like right here. So we have these two planes, one at z equals 0, one at z equals 6. And the area of our inequality is everything in between here, a sandwich, if you will. A large infinite sandwich which spreads forever in the x direction, forever in the y direction, and is limited by 0 and 6 in the z direction. Our next one is x squared plus y squared equals 4, and z equals -1. Now, as you know, x squared plus y squared is the formula for a circle. So I drew a circle. So we're going to pretend that this is a circle of radius 2. And it's x squared plus y squared, meaning that it's in the xy plane. and it's at z equals -1. So we'll imagine, we'll look this up a little bit, and we'll say that this is -1 on the z-axis, and there you go, circle. Our next one is x squared plus y squared plus z squared is less than or equal to 3. Now, we're going to learn that the equation for a sphere, and I made one, is x squared plus y squared plus z squared. The 3 being an indication of the radius squared. So we're going to pretend that this is a sphere of radius radical 3. Now it's saying x squared plus y squared plus z squared, indicating that the center of the sphere is at the origin. So I'm going to put the sphere at the origin. So here's our sphere. And it's an inequality, so it's saying that it's less than or equal to 3, meaning that our sphere, even though my sphere is a shell, it's solid, it's everything, all the points that are in between this sphere. Now, our next one, 33, is x squared plus z squared is less than or equal to 9. Now, first things first, we realize that x squared plus z squared is a circle. Here's our circle. It's an x squared plus z squared, so that means it lies in the xz plane. And it's saying that it's less than or equal to 9, indicating that it's a solid circle. So I'm going to switch this for a solid circle. Now, there's no y value given, no limits on the y value, meaning that this circle, these values will go infinitely in the positive y direction and infinitely in the negative y direction. So it will look more like a cylinder that goes forever in the positive y direction and forever in the negative direction. So for this answer, we have a cylinder of radius radical 3 that goes along the y-axis forever in the positive and forever in the negative.